Good evening students. In this section I am going to explain that what is parallelogram law of vector addition. Okay. So firstly I want to just give you the basic idea of this parallelogram law. So as it is just clear from the name that somewhat law is related to parallelogram. So just see here, let's suppose any parallelogram I am just drawing. ABCD is a parallelogram. Okay, so what are the basic property of that? Opposite sides are parallel. So this AB is parallel to DC and AD is parallel to this BC. So according to this particular law, if any two consecutive side of parallelogram is representing by two vectors in magnitude as well as in direction. So I am just taking a side AB as well as this AD. These two are adjacent side. So let's suppose this AB side is represented by the vector P, okay, and this AD side is represented by the vector Q. So according to this law, if two sides of any parallelogram is representing by two vectors in the magnitude and in direction, so the resultant of these two vectors will be the represented by the diagonal of that particular parallelogram. Before starting, I want to give you basic idea. Let's suppose we are knowing this thing that AB and DC are parallel with respect to each other. So parallel side represents by the same vector. Means if P vectors is applying in this AB direction, so same in the DC direction this P vector can be applicable from the projection. If I am just projecting this particular side on this, so both are the parallel, so vector will be also same. And same as for AD and BC. If AD is represented by vector Q, then BC will be also represented by vector Q. Okay, I hope this is clear. One more thing, this is important, that always we have to take an angle from tail to tail joining. This is a point where tail to tail are connected. So at this particular point we have to just take an angle. So let's suppose the angle between these two vectors is what? It is theta. Okay. Now we have to check whether it is valid or not. From the graphical method of addition we can just check it out. Okay, just see here the AB and BC only firstly. Let's suppose if AB and BC are two sides and on which the vector P and Q are applying. Okay, so in a graphical method I just told you that in the normal addition we have to just add the head of one to the tail of another. So for this particular AB, it is arrow is towards the B side, B point, it means this is head and A is what? Tail point. And same manner for BC, the arrow is towards C, means this is your head and this is what? It is our tail point for this BC. Okay, so this is the point of joining or the point of the combination. So just see here at the point of joining, head to tails are connected. So now it is valid now. But for joining a resultant, what is the resultant? Resultant is the closing side for this one. So if I am just closing, if I am just meeting this point A to C in a straight line manner, so this is what? This is our diagonal of this parallelogram and the resultant will be represented by the diagonal. According to definition, if two sides are representing by two different vectors, then the resultant will be represented by its diagonal. Means the resultant will be R and the arrow will be what? How resultant can be added? Tail to tail and head to head. So resultant head will be towards the head of this particular and its tail will be connected to tail. Always you need to remember this thing that resultant will be added head to head and tail to tail. This is very important. Just see for these two vectors also. Okay. D is the joining point of this particular Q vector and P vector. So it is towards the D, means this is head point and it is towards the C. So it is head point and it is tail. So at the joining point head to tail is connected, it is all right. And for making a resultant, we have to just join these 2 points. So now I'm joining. So the resultant head will be towards the head, just see here, and its tail will be towards the tail. So now it is valid now. So that only we have to just prove. Okay, that if two side of any parallelogram, any two adjacent side of the parallelogram is representing by the help of the vectors in magnitude as well as in direction, so their resultant will be represented by the diagonal of that parallelogram, and by the graphical method it is very clear, and I hope there is no problem. Okay, but now we have to just find the relation between this resultant magnitude and the vector's magnitude. Okay, so let's suppose the angle between the vector is what? Theta, which is already, I just told you, tail to tail connection will be there. Now for finding a relation, I am just producing this particular line AB in a forward direction. Okay, so let's suppose I am just producing this particular line in the forward direction, and from point C I am just going to draw a perpendicular on this produced line. So let's suppose this is our perpendicular line, and this is a point of connection or the point of intersection. I can take E. Okay, I can take it E. Now what we have to do? Okay, just see one thing which is important. If this angle is theta, okay, so these two lines are the parallel lines. Okay, so by the corresponding angle, this angle will be also theta. If these two, let's suppose, just see here, if this angle is theta, then this angle will be also theta. If these two lines are the parallel and it is the transversal line. So by the same manner, we can just write, if this is theta, then this will be also theta. I hope it is clear. Okay, let's see further. Now we can just project this particular vector q in the horizontal as well as in the vertical direction. Okay, just see here in this triangle CBE. Okay, so let's suppose our triangle is CBE, where angle is what? Theta. Okay, and in BC direction particular, q vector is there. So by the cos theta we can get the value of B, and by the sin theta we can get the value of C. So from the relation we can get here the B will be q cos theta and EC will be represented by q sin theta, where q cos theta is the projection of q in a horizontal direction and q sin theta is the projection of q in a vertical direction. So we have to just substitute it. In a B direction it will be q cos theta, and EC, that is the perpendicular line, that will be the q sin theta. Okay, this you need to understand, it is very important also. Okay, let's suppose resultant, this resultant R is making an angle alpha with this vector P. Okay, means resultant is making an angle alpha with this vector P, because we need to just find the direction of the resultant also sometimes. That is why I am just considering this angle as a theta. Again, this is the angle between the one vector and its resultant. Okay, now just see the right angle triangle ACE, because this is the perpendicular line, so I am just taking whole the triangle. Just considering right angle triangle ACE. Okay, in this particular triangle we have to apply the Pythagoras theorem. Okay, so according to Pythagoras theorem, the square of the hypotenuse is equals to the square of the base and square of the perpendicular. So that we have to apply only. So from this theorem we can apply what? That AC means hypotenuse square is equals to perpendicular square, which is your CE square, plus base square, which is your AE. Because I am just considering whole the triangle ACE, whole the triangle I am considering. So CE square plus AE square. Now we have to just substitute the vectors in the side direction. Let R is a resultant vector which is applying in the AC direction. So in a place of AC I am going to put this R. In a C direction Q sin theta is there, and in A direction from A to B P vector is there, and from B to E Q cos theta is there. So for whole direction in AE the vector will be added because both the vectors in the same direction are applying, so that will be added. Okay, so I am just going to putting all the values of resultant and the vectors. In a place of AC R is applicable, so R square is there. C की place पे Q sin theta. So in a place of C we can put Q sin theta of square plus AE square. In the direction of AE P plus Q cos theta is there. Okay, why P plus Q cos theta is there? This is also important. Just see AE. If A is there, so how we can just break it? A can be break in two parts, AB plus BE. We can write it or not? We can just write AE is equals to AB plus BE. In a AB direction vector P is there, in a B direction Q cos theta is there. So whole vector will be, means whole term AE can be break into P plus Q cos theta. Okay. So A is equals to what? P plus Q cos theta. So now I am going to put in a place of A these two values. So it is your P plus Q cos theta of whole square, because A square means this whole term square will be there. Now I am going to just solve it. R square is equals to Q square sin square theta. Here A plus B of whole square identity I am going to put. So P square plus Q square cos square theta plus 2PQ cos theta, because A square plus B square plus 2AB. So from that relation I am going to put. Now what we can do? We can take common Q square from these two terms. Okay. So R square is equals to, if I am going to take Q square common, then you will get sin square theta plus cos square theta from this two term, and again rest term we have to just write it in same manner, P square plus 2PQ cos theta. This is our identity which is equals to 1. Sin square theta plus cos square theta is equals to 1. So here it will be 1. So what you will get? R square is equals to Q square plus P square plus 2PQ cos theta. Okay. This is our relation between the magnitude of resultant and the vectors magnitude relation. Okay. And from here you can get the value of R, that will be under root of P square plus Q square plus 2PQ cos theta, same as the triangle of vector addition. Okay. Means if two vectors are adjust with making an angle theta, so their resultant magnitude will be arranged in this manner. This is very important, you need to understand it. Okay. So this was our expression. Okay, I am just going to give you some basic idea regarding that how the vectors are arranged. Let's suppose if two vectors A and B, let's suppose, or P or Q, if the two vector P and Q are applying in the same direction, let's suppose this block is there in which P and Q forces are applying in the same direction, then how its resultant will be modified from this formula. Okay. If two vectors are in same direction means parallel to each other, so what will the angle between the vector? That will be equals to theta. So for same direction, same direction means parallel to each other. Okay, theta must be equals to what? 0 degree, and your equation will be modified like R is equals to under root P square plus Q square plus 2PQ cos 0, and cos 0 value is what? It is 1. It means R is equals to what? Under root P square plus Q square plus 2PQ. What is it? it is just a square plus b square plus 2ab, means a plus b of whole square. So in place of it we can just put r is equals to under root p plus q of whole square. If there is a whole square and whole of under root means power 1 by 2. So we can just substitute it like this, p plus q of whole square, and the whole power is what? 1 by 2 due to this under root. 2 to 2 cancel out and we get the result r is equals to p plus q. So this parallelogram law explains that if two vectors are applying in the same direction, so we have to add the magnitude of both the vectors to get the resultant, and it is very clear also. Let's suppose I am just pushing this particular wall in this direction and someone is also just putting in the same direction, so both the magnitudes will be added, isn't it? So that is why it is clear. Now let's suppose two forces are applicable on a particular block in an opposite direction. Okay. So if two vectors are applying in opposite directions, means these two forces are anti-parallel to each other. Okay. Why anti-parallel? This is the direction of P and this is the direction of Q. So now the angle is what? 180 degree. Angle is what? 180 degree. So from same formula, if I am just putting here in a place of theta 180 degree, so if I am putting for a opposite direction, if theta is equals to 180 degree, then what modification will be there? In a place of here we have to put 180 degree and cos 180 value is -1. Okay, you have to understand this thing. Cos even pi is always +1 and cos odd pi is always -1. Always just remember these two terms. So cos 180 is what? -1. So -1 will be multiplied with 2pq and that will be minus, means p square plus q square minus 2pq, and here p minus q of whole square, and here also minus and here also minus. So that is very clear. If the two forces are lying in opposite direction, then the resultant will be the difference or the subtraction between two vectors. Okay, this is very important result. So that explains that why in a general basics we take it as a same manner or in a opposite manner. Means if I am just pushing wall from this end and someone is pushing this wall from another end in opposite direction, so both the forces will be subtracted. Both the forces will be subtracted to each other. Okay, one more thing is there related to parallelogram, that how to find the direction of the resultant. Okay, so this was our general figure in which this was our R and this was the angle alpha. It is our P, it is Q, and it is what? Q sin theta and Q cos theta. Okay, if in this particular, let's suppose A, this point is B and this point was whatever E. If I am considering the right angle triangle ABE, what? ABE. I am considering a right angle triangle ABE. Okay, in this particular triangle, if I am taking a tan alpha, what I am taking? Tan alpha. So tan alpha is equals to perpendicular upon base. In a perpendicular, q sin theta is there. In a base direction, p plus q cos theta is there. So tan alpha is equals to what? Q sin theta upon p plus q cos theta. So this is generalization formula for finding a direction of the resultant with respect to any one of the vector. Okay. From here, alpha is equals to tan inverse q sin theta upon p plus q cos theta. This is our general parallelogram law. In the next few videos, I will discuss the vectors again, then I will just give you some practical examples. I hope that this video is somewhat helpful to you. Stay tuned to our channel. Thank you, class.